In this way, I have created the current command for checking. And when it is determined that there are no issues, we need to add commands like what is the command now and how long is the data. Let's extract just the data. I will try to add that by linking and using multi-data and stun data with multi-caching. We can do it the same way, just with the correct buffer. Then, instead of stun data, since this is data, we can use void packet get data so that we can retrieve either the entire data or just a portion of it. However, this can be a bit inconvenient to set up. To elaborate further, the process of creating the current command involves a series of steps that ensure accuracy and efficiency. Initially, the command is checked for any potential issues. Once it is confirmed that there are no issues, additional commands such as what is the command now and how long is the data, let's extract just the data, are added. This step is crucial as it allows for a more comprehensive understanding of the data. Furthermore, by linking and using multi-data and stun data with multi-caching, the process can be streamlined. This method ensures that the correct buffer is used, which is essential for accurate data retrieval. Instead of using stun data, the void packet get data command can be utilized. This command is versatile as it allows for the retrieval of either the entire data set or just a specific portion of it. However, it is important to note that setting this up can be somewhat inconvenient. Let's organize and tidy up the line breaks, since we might use each command position quite frequently in our code base, length position, as well as data position, quite a bit more often than expected. It would have been good practice to start from this point right at the beginning itself. However, I thought it would make our discussion unnecessarily longer, so I didn't proceed with that approach initially. For example, if you define qsren1 as define post cmd2 along with a define post date3, then it would indeed be beneficial for us to rearrange these positions here accordingly. I don't have time right now, so I'll skip over it for now since it's getting too long. Next is get data ranked. As you can see now, it is indeed the length of the remaining bytes, excluding the STX byte. However, if you subtract one CMD, one checksum, and one ETX from the length of the remaining bytes, you get the data length. The data length is variable, so subtracting 3 from this LAN gives the actual data length. Deducting 3 from the shot data plus packet POS rank gives us indeed a straightforward data rank, and then it's simple enough. You just need to use, moreover, an additional command for data plus packet POS rank. Honestly speaking, to make this easier for you all, you could use memcp from within. In fact, the string library itself. But since I've been controlling various hardware MCUs over time, I've found that memcp works well sometimes, and not at other times as well. So I prefer not to use it if possible at all costs. Moreover, additionally, using memcp requires including. Furthermore, the string library itself again, which can often put a significant burden on memory resources overall. So I find that using a loop instead of copying memory like this is generally considered as being one of best approaches. It's very convenient and easy to use. I have carefully set it up so that the values in the source, memory, are copied directly and accurately to the destination, memory that we want to move to. Let's thoroughly check it out now. First, let's examine the data rank in detail. link, 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 Finland, and by calling getCMD directly, we can check this in hexadecimal format, which is a base 16 number system used in mathematics and computing, since we only used one piece of data for Vinland here, which is a fictional land used for demonstration purposes. I just used a single unit fight variable, meaning only one variable was needed for this specific instance. However, if there are multiple pieces of data, we can declare and use an array variable, which is a data structure that can hold multiple values at once, allowing for more complex operations and data management. We just now obtained the source data length. Data here. Next, we need to change the data length into point shape. So let's do that. To make it easier to check, I'll use hex for this. Let's try uploading it once. Oh, there's an error. It's not packet, force, rank, but range. Let's complete the upload. If we look at it, we see packet OK, data, rank 1, command 0, and the data comes out perfectly from CA. This time, we created commands to check the desired information from the accurate packet. Next, we need to change the data length into point shape, so let's do that. To make it easier to check, I'll use hex for this. Let's try uploading it once. Oh, there's an error. It's not packet, force, rank, but range. Let's complete the upload. If we look at it, we see packet OK, data, rank 1, command 0, and the data comes out perfectly from CA. This time, we created commands to check the desired information from the accurate packet. Next time, we will use two Arduinos to have one send packets and the other receive them, and then we will demonstrate the results. I will see you next time.